hurts. Okay, so, hi, welcome, thanks for coming. Here's the long title that we've chosen. So, let me just ask a couple of questions here before we start. How many of you would tell me that you've written a HAL before in LabVIEW? Okay, a lot of you. How about a MAL? Both? Okay. How many of you, now that LabVIEW 2019 is out, how many of you are now going, hey, yeah, we're using LabVIEW 2019? Okay. Oh, all right, one person, good. LabVIEW 2018? Oh, all right, a lot. And older than that? Okay, still some, yeah, okay. All right, good. All right, so we'll see what I'm asking. So I'm Joffrain, I'm a chief software engineer. I'm on the LabVIEW team. And here with me is Ryan, so I'm going to have him start the presentation. You guys hear me? Can you hear me? Project across the microphone. One more time. Alright, that's as much as I'm going to move it. Hopefully it's better, and I'll try to project as best I can. Alright. So, it's our very long mouthful of a presentation. What we'd like to go over today is kind of our perspective into the importance of extension when designing HALs and test frameworks. We'd like to share why that's important, kind of the rationale about how we use these patterns internally, and then how you can actually implement these extension points in LabVIEW and LabVIEW 2019 when you go back to your companies. So to start us off, just define extensibility so everyone's on the same page. When we talk about the software that we're developing, it's the quality of being designed to allow the addition of new capabilities or functionality. So it's allowing for change. And so why is that so important? When we develop a framework or a HAL or test standardization in general. And to answer this question, I'd like to go through kind of our journey internal at NI. It's kind of a case study of what we've done in the last few years. So what you see up here is kind of the hardware product life cycle at NI. Starting on the left is the beginning of development, and then it extends to the right into the future. And you can see that during the hardware life cycle, it actually goes through a couple different test domains. B, production, maintenance or support, which includes things like calibration or RMA or services. So you might see similar structures in your own companies or your own customers. And when you look at this actually works pretty well. And it worked pretty well for us until this timeline here got really long. And so we started looking at projects that would go into B&B and we'd spend 6 months to a year on B&B. And then after B&B, we get into production. We'd spend 6 months to a year getting through production development. And then another 6 months to a year doing calibration. We started looking at that and we were like, is there something we can do to make this more efficient, to make this less costly? And so when you kind of back up and you look at it, those test domains kind of need the same thing, at least at NI. When you're trying to automate hardware testing to verify and validate specifications, that kind of spans everything. And this is a theme that I saw at least 3 times in the keynote today, or the keynotes, is trying to get some level of software reuse or standardization across different test domains that don't traditionally work together. So when we looked at that problem, we did find that there actually was quite a bit of overlap between the groups. And when we kind of drew out what the DNA of those tests look like, maybe a template here, they actually kind of perform pretty well. And so in the typical test flow, and not going to know all of what we're doing here, but you kind of see we go through initialization, configuration, measure, log, and close, and what we found is that there were dozens of implementations of each of these buckets in NI. They were by and large doing the same things. Only we had different owners, different support. Some things were good quality, some things were bad. And so we looked at how can we reuse some of that code? Can we make some of that more common and used across different groups? And so when we looked at the problem, it presented a few challenges. These test domains actually have different schedules. In that product lifecycle, they have different care abouts. They're usually different orgs or groups. And they're working on different schedules. They have different capital equipment needs. Sometimes they're at a bench top. Sometimes they have a rack. Sometimes they're going into the field with a portable equipment. And they have different automation needs. So some of them are long-running, some of them are short. Some don't automate much at all, but still write tests that they're doing by hand. And so here we see the first sign of, as much as we want to share code and make some common code, there are some differences that we need to represent in the system and in design. And so addressing all of these differences while also meeting our success criteria is one of the challenges we're trying to show today or solve today. So some of the success criteria is all about cost reduction. So we have reduction in test development costs, reduction in the time it takes to run a test, reduction in the cost of maintenance, so that total cost of ownership side. And then after all of this is said and done, we would really like to increase quality in our solutions. So this isn't the very first time we've done or tried to attempt a test standardization effort. It's not the first or the last one we'll see in our customers. And we kind of did an analysis before we jumped into our designs on what we thought might have failed in the past. What could we correct in this go-around? And two of the main takeaways we had were we had a bit too much model inflexibility. So again, we get some Extensibility shades there. And we didn't quite design the ownership model of this code well enough. And I'll go through that real quick. So here's an example of model inflexibility. So when you start a HAL, for instance, you might be very product family centric. It might be, okay, I want to represent a DML, and I want to represent a digitizer. And then you start, as time goes on, you start getting into the corner cases. You start getting into the instruments that actually span product families, like this 4081. It could be either a DMM or a digitizer on your block diagram. Or you start finding instances where your instruments can actually be fulfilled by a combination of other instruments. Same measure. And so just as an example, when we kind of went into this in great detail last year, you'll probably find some links to this presentation for you. This is kind of our answer to it at the time, and still is, on how we might abstract some of those differences away. And we decided we're going to abstract capability versus the product families. So it's very much more measurement-centric. And you can see here another instance where you start seeing some extensibility. We have some baseline code that is being extended or inherited into specific instances of maybe a DMM or voltage acquisition. And then we have ownership misalignment. So if you are anything like us, if you are going and trying to do a test standardization effort or hardware abstraction layer, you probably have a small group of engineers in the middle that's actually owning and implementing that solution. And they serve a bigger organization, maybe test engineering. And then they serve a bigger organization, maybe product engineering. So there's this span out of support that's needed. And we felt like in the past, when we were not clear about the differences and delineations between the ownership and the groups, we started getting into trouble. So this center circle is actually way too small to actually support every single difference that our customers need. We had B&B, test engineering, calibration engineers, sustaining engineers, and for every single difference, they couldn't come running to us on their own schedules to fulfill their needs. And we didn't have all the expertise. So we got really clear about what we own and what other groups would be able to own. And whenever we started talking about other groups owning pieces of this design, it's a natural point for extensibility. We need them to be able to take some common code and make it their own. And so what that looks like with that previous example for the HAL and the MAL is something like this. So the test service team might be defining what the base driver is, or base functionality. And then the test domains come in and they actually add their expertise, their domain expertise on the right methodology, the right instrumentation, and they start filling in these pieces that are very specific to their solutions. And so this was kind of this distributed ownership or shared ownership model that we started to design to address our issues from the past. And so all of this is to say that when we were looking at designing our HALs and frameworks, extensibility became very key. We needed some standardized flexibility. So I'm going to hand it off to Phil to talk through some of those specifics on the flexibility.
We're going to be trained not to keep you guys awake. Here we go. And not fall. All right. So now that you're convinced extensibility is obviously very key, very important, let's say that we want to look at a framework. And let's say that we want to look at an abstraction framework pattern, and you could recognize that this is probably very typical, where there's some form of configuration that needs to occur. There's some sort of loading of your parameter, your configuration. You want to load some actors. Now, in this case, you could say that it's, I'm about to perform an operation, I'm about to do a measurement, I'm about to do something, and so I'm calling them actors in this use case. And then you want to perform that action on the actor, which could be acquiring data, generating your voltage, something to that degree. There's then, you want to validate it, so you want to verify that result, and then maybe log it. And you could argue that a lot of your clients probably want to do all of these things differently to a degree. Interacting with some of our clients, and we go, hey, you can load your parameters, let's say from Excel. And they go, great, we love XML. It's like, okay, well then that would be a good extension point for them to be able to do that. So here are the things that we're making the case that anything in the light green is a place where we felt it was important to be able to extend. Obviously, the framework at some point that we want to provide potentially has things we don't want to overwrite. Right? It's the framework, there's some initialization, there's some cleanup. We want to obviously own that part. But knowing that there's pieces that we'll never think of, it turns out there's a new way to verify a measurement, there's a new way to log a piece of data that we don't want to make that call, we'd like to make our clients make that call. So then, here are some examples of where they may want to do that. So it could be, yeah, like I said, loading parameters in a certain way. It could also be remote. Oh, it turns out that right now we load them from an Excel file. Well, what about a database? What about somewhere else? It could also be, in this case, so for the different loading actors and performing, it could be the HAL and MAL use case that Ryan was just talking about, which could be at a very high level of, I want to acquire voltage, I want to generate. But on the HAL, it could be, well, here's the specific device that I want to interact with. When you want to do your verification, there may be limits involved. Right? You want to compare, you want to validate against the Boolean, well, there's probably not a limit involved. But being able to specify the type of validation that you want to perform. And then for logging, you may want to push the system, or you may want to push to TDMS, or even just a plain text file, or even then, again, to the cloud, somewhere else. And then, by the way, feel free to ask questions as we go. As we go. We're flexible. All right, so here are the things, the key challenges that we felt were necessary to look at when extensibility was important, which is what pieces do we want people to extend? How do we want to receive that? If I'm a framework maintainer, then how do I want to let them extend that functionality? And then being able to balance ease of use versus that flexibility, right? I could give them all the power and have them go, yeah, but I can't do it. It's way too complicated. Or the opposite problem, which is, it's so easy, but I am so limited. And so finding that balance is always very key. And then how do we do all that and yet keep the core framework performing? Because running tests or whatever your framework enables probably has to work as fast as possible and as money. So these are all the things that we had to consider. So if these are the extension points, the other thing that you might want to look at is coupling or componentization, which is you could tell your clients, hey, just extend this big thing, but they might go, wait, really? The minute I want to extend anything, I have to rewrite it, the whole piece? And that obviously doesn't scale very well, or it's not easy to use, let's put it that way. So thinking about componentization might be key, where you might say, you know what, I'm going to start by overriding or extending the way that I load parameters. It turns out that's the key. The framework provides the default, I'm okay with it, but I want to change it for this particular thing. And then boots your way to, hey, the next thing I want to extend is the way that I log my results. And so being able to think about where you want to delineate the extensibility is going to be key. All right, so let's talk about some of the tricks that we've used or mechanisms that we've used to allow this to occur.
Okay. Did I position that right this time? We're going to start going through actual design challenges that we came across and how we solved them in lab. And this format will be pretty consistent throughout the presentation. We'll go through and kind of highlight where in the extensions we felt this pattern applied, some of the objectives we wanted to fulfill, and then we'll go through the actual challenge, what we were trying to allow our clients to do. So in this case, I want to replace base functionality in the framework at all. So any of these green boxes, how do people extend them? So we need to provide a mechanism for developers to extend the base functionality on their schedule, not my schedule, as a framework developer. And we want to reduce the maintenance burden on framework maintainers. So that's actually pretty key. You see this throughout. There's a big stress on the team when everyone starts asking for different things. We try to distribute that. So to replace base functionality, we're looking for something like this. We can exchange one piece of code on the left here with a piece of code on the right. So the challenge is to replace code implementations without rewriting the entire test. We want to replace pieces. We want to allow dynamic runtime code replacement. We want our clients and our developers to easily find where they can replace code, what they can do, what they can overwrite. And we want to enforce key policies and implementations. So in some places, we actually want the framework to help people out, and we don't want that overridden. So one natural way that you might think to solve this is BI Server. Been around forever, it's very capable. But I want to call out that it didn't quite solve all of our specific needs. So in this case, we could replace the code implementations without rewriting the entire test, and we allowed for dynamic runtime replacement on code. So I can just give a path to VI, and it'll load it at runtime and execute. But we didn't feel that this was easy to discover for our clients. A lot of the times, you don't actually see this call on a block diagram. It's underneath a sub-VI somewhere, kind of hidden away. It can be really granular because you're talking about a single VI. So if you had a whole suite of functionality that you wanted to replace, you're now replacing a whole lot of calls. You've got to go track down what each interface looks like. And so it's a little harder to manage for our clients. And then it doesn't actually do a really great job, we felt, of enforcing the key policies and implementations. If you can do this, you can replace everything. So we wanted to get a little bit more control back. And so enter classes. And I know classes have their place, and there's reasons to use VI Server over classes sometimes. We are using classes in this design, and you will see it throughout the presentation. They really work well for what we're looking for. And you can see I got all these green check marks. The reason that we really like classes is it provides a guided extension experience. It's not just a BI call on a block diagram. There's a whole structure in place in the editor to let people discover what is overwritable, to replace suites or groupings of functionality at a time, and for building scope and enforcing policies on what must be overridden or what cannot be overridden. So we have a lot more control and flexibility here with classes. All right, so now you're going to see classes from now on. Established the user. All right, so let's talk a little bit about loading and using actors. Don't get too hung up on the name actors. We're not all actor framework, everything. It's just a piece of functionality we want to replace in the system. So we want to provide a consistent experience for selecting from available actors. We want to create a system where it's easy to discover what options you have to choose between. It's not just always limited to the disk. And I want to reduce maintenance burden on framework maintainers. All right, so this is kind of what we're trying to achieve. And I'm going to call back to, here's our class wire, this is the dream thing. And that's actually representative of the function layer in that previous HAL set. So we want to load the actor, load the new functionality, and we want to perform the functionality. Like that. So the challenge is to easily select between actors. And further, I'd say we want to guide the edit time experience. We want to be able to select this in a way that this action we're performing is somewhat specific to the selection of the developer. It's not just the highest level parent implementation, that we actually have some granularity there if needed. We want to enable the seamless importing of the user-defined actors. We want to load the minimum number of active classes in the memory. And this was not our original goal necessarily, but it is a differentiator in the designs. So we're going to talk about why this became so important. We want to make it easily extensible without changing the actor selector. I'll show you why that becomes important as well. So you might say, okay, first off the bat, we'll just directly call some sort of class factory or selector, and then we'll get a green wire out that represents a whole class of functionality. So we felt that this didn't actually let us easily select between actors, unless you count easily selecting as going and finding a new BI call and putting on your block diagram. And the enable the seamless importing of user-defined actors, that wasn't really seamless to us. We had to go and find this new loader or override the factory every time someone wanted to change this. So we didn't really like that. But it did allow us to load the minimum number of actors into memory because this can output a single wire if we want. And then easily extend this for actors. So we can do that. So since we're doing selection, you might think, hey, what about a polymorphic BI? And we looked at that for a little while, and it had a few negatives in this particular use case. And the biggest one was that when you drop a polymorphic BI down, every single instance of the BI is loaded into memory, because it doesn't know what you want to select. And so on the block diagram, when this loads, all of these implementations are loaded. And for a large network of classes, that can get quite large, and you don't actually want it in memory when you've already made one selection. So, one of the other things is this does not allow for the easy extension of the polymorphic BI to select. That definition right there is static. So, if I provide this as a framework developer, then I am extending it as a framework developer every time someone has a new thing they want to represent in the system. So that wasn't our favorite option. It turns out, Express BIs work really well for this, for our use case. And so, here's some of the things that we liked about Express BIs. Express BIs, when you drop them, or right-click configure them, or double-click them, you can actually pop up this dialog, any dialog, that you have control over the implementation of, to select or configure what the code should be doing. And in this case, or the way it works is after you make this selection, you actually get a scripted version of the Express code. uses a template and it strips out all the types. So in the end, if I selected one class out of a drop-down selector of classes, it would only load that class on your block diagram until you double-clicked, reconfigured it, and you get one more class. So this actually gets us down to the minimum number of classes in memory, and makes it easy to select. And in fact, we created this selector to go look at different places on disk. We said, hey, here's the contract. If you put a class in a different location on disk, then we will not overwrite it for our next installation, and we will go and honor it and find it for you when you pop up this dialog. So we can have any number of new implementations enter or exit the system, and it doesn't, the user can always find it. And you can use any implementation you want at that point. And just to note that Express APIs are also portable, just like any other piece of code, which is useful when you're delivering a library to your clients to use. It doesn't always have to be into an install vi.lib, it can just be provided along with your code. All right. So, now I'm going to move on to another challenge that we came across. Handling data and data types. And this is such a simple statement, you're like, yes, data types exist, and we need to use them. Great. But we want to provide multiple data types, and we want to support them while also promoting code reuse. And reduce the maintenance burden on the framework. So just an example, I want to show you how this explodes for a framework maintainer. So in this case, I've got a double in. We do some sort of work on that double, and we have a double out. Super simple example. But I don't want just doubles. I want all sorts of integers and numeric types. I want string booleans, scalars. I want clusters, complex data. I want arrays of these types. I want to put that work inside of a sub-VI, which is now wrapped in another VI. And so you get this nesting. And what happens is this explodes the number of VIs you are maintaining. So I've got a version of all of these types, all the nesting structures. It can get to the hundreds. And so this one had a number of challenges. I'll go through real quick. We want to create shared code for a number of supported types. So I don't want people to keep rewriting how to transform a double or an array of doubles. I don't want that. We can provide that. I want to enable users to extend shared code with their own types. I want to reduce the number of maintained VIs and avoid copies when passing data through the system. That goes to the overhead of the framework and how we want to reduce it. I want to provide edit time feedback over runtime feedback. I'll show you why. So, I can start with the basic example. Here's type-specific sub-VIs. And we just talk through how this explodes. And I'm going to just point out this use case, so you're going to see it a few times. I'm doing a very simple array in this case, we're representing with the double. I'm taking the third element and I'm duplicating it inside the array and I'm passing it. So it's not something that primitive does for you, it's something you might have a sub-VI for. Kind of a contrived example, but you can put a new piece of code with. So one of the patterns you might see often is, let's just use variants. Variants can take any type. So I can provide one implementation for everyone, and then they can just give me any type, and it works. And I posit, this isn't really ideal. You're kind of breaking the library type system knowingly, and I've done it myself. I'm guilty of this. But this doesn't do a great job of enabling users to extend shared code with their own types, because if you look, the type handling is inside this block. So who gets to extend it, who gets to change it whenever someone wants a new type? Back to the framework developer, usually. It does not avoid copies when passing data around. So every time it goes through this variant conversion, there's probably like, I think when I highlighted it, 4 different buffer creations in this example. And that's problematic when we start talking about complex, large types. And it doesn't provide any edit time feedback to users. They can literally pass anything into this, and they won't know until they run it whether it's good or not. So that's not quite ideal for us. And also, I added these to the side. This is also not really clean code. I don't like it. It means the person. Block diagrams get really messy with this implementation. You can go with polymorphic VIs, or some sort of selector. Same drawbacks as before. It statically defines the number of types, but it does avoid copies. It's just literally one implementation. It just explodes the number of VIs you have to maintain. So I didn't like this one either. And this is where Malleable VIs actually have a really good use. The Malleable VI looks something like this. You can see I've got my duplication code, and it's doing a check right here that says, hey, are you an array? Just, are you an E-ray? And if it was any array, we can use these primitives for any array. It works. This is one implementation for all data types of arrays you can possibly pass into this VI. It's a pretty good example of effective use of Malleable VIs. So we're able to fulfill all of our challenges within shared code for a number of types, enabling users to extend shared code with their own types. You could pair this with class use, where you pass in classes or interfaces using more bins or interfaces on classes. You can use things that any primitive can do. This kind of design allows for kind of algorithm work. You might do the same thing over and over on a whole array. It avoids the data copies, and I'll show you why in a second. And it provides edit time feedback. If I wire something in that does not accept if I wire in not an array, any scalar type, it's actually going to break the wire. And it's going to tell my user, you can't use this with the scalar. It only works with arrays. And so the way that works is it uses type propagation. When you implement a vim, you put your connector pane in place, and when a user wires in an input, it takes the type of that wire, it propagates it through the inside of that VI. It caches it off into the object store, creates an instance of it with that type propagation. And at that point, everything about that VI looks like it uses the new type of the user passed in. It just uses type propagation, which is why the wire can break and tell people at edit time that it's broken.
Does that still work if you have a string array in and you want to switch it to a double array out?
So you can actually mix and match the inputs and outputs. You don't have to match it. All you have to do is fulfill the point where this wire, whatever came in, is going to type propagate through. So if you had some code that turned a string into a double, that would just be fair game, right? So, and you can do more than one input as well. All it does is say, whatever you put on the input, it's going to type propagate through, follow all the wire branches you have. You have a new instance of the VI with your user's type. There's no data copies. So it works really well for this use case. Let's recommend this. So now I'll pass it off to Phil for some more examples.
All right. So you guys are already all using VIMs, right? No, all right. And you're all using 2019, right? No. All right, there's only one hand. Okay, let's see if this can help you. So, here we go. So one of the things that we want to make sure that we do as part of any framework is we usually have some data, usually a lot, that we have to store and maintain. And that data type can be a lot of data, it can be a little bit, and sometimes of different types. So one of the things we wanted to look at, and we're going to look at some new 2019 features for 2019, that you may want to use. So one of the things I want to show you is how we were able to reduce some of our own code complexity. The examples I will show are fairly simple, but I think you'll see very quickly where you yourself might find some benefits. And also, this is really where we go and realize how important execution speed can be. And anytime we're accessing a lot of data, a lot of times is where this becomes important. So, most of you probably used variant attributes. Yes? Please raise your hand if you use variant attributes. Yeah? Why? It's a fast lookup table, right? Why didn't you use something else? What's that? There was nothing else. Yeah, I've given whole presentations on all the benefits of variant attributes and their speed and all the benefits. So you may have something like this. So in this case, what I do want to show is that there is a place for variant attributes. Let's say that you want to store on the same path different types of data. Well, this is where attributes on a variant are very useful. You can just about pass anything. So in this case, we can just use it almost like a property map. Anything you want to store in it, it stores. Right? So this is great. It turns out we can specify a wide range of types. But there's not a whole lot of flexibility in the key. Notice that they all say attribute 1, attribute 2, attribute 3. It turns out that's a string, and that's pretty much all it's ever going to be. So, and notice I'm stopping right there, because right now I'm going to show a little bit later what I want to do for performance, and then readability. So, introducing maps. You guys are aware of maps? There's now maps in LabVIEW 2019. Welcome to the future. So, here's what a simple map looks like. You have a string key, same as a variant. And then in this case, let's say I have an integer as my value. You could say that I'm doing instance count, right? Anything that matches a certain key, let's say I'll increment the value. So in this case, I'm kind of matching a lot of these. But you can also do the opposite. It turns out that I want my key to be a numeric. And the value is actually a string. You can say I'm doing some bookkeeping. Let's go a little more crazy. It turns out I'm doing dependency inspection. I have a source and a target, and I want to keep track of their paths. In the paths that I've done this, I've concatenated two strings with a delimiter to say source, let's say arrow, target, and then I resplit it later when I want to make use of that key, because I'm kind of using the key as a pseudo value. Well, it turns out that you can just pass it a cluster, and the minute the cluster matches, there's your result. I love this. Let's go a little more crazy. So let's say that you might have some test results, and all you want to keep track in your map is the return value, whether it passed or failed. So now I can have my key be the test result, and then my value is just whether it passed or failed. This is crazy, don't do this. Also because if you have a numeric in your key, especially a double, if it's not 100% correct, I'm not sure you're going to match it. You can also nest maps. So right now, here's your 2D, 3D array version, if you like. So now, oh yeah, and by the way, if you're like, oh well, yeah, but I also like keep track of any data inside my attribute system. Well, okay, we'll just put a variant in there, and now all of a sudden you've got a map that contains a variant, and you have all your old functionality. You could argue that in this case, the key to your map is also the key to your attribute, just in case you want it. Right? Again, not a great use case. I'm just letting you know you can. Okay, there's also some cool actions that you can perform on a map. So you can also say things like, hey, I want to in place delete an element, I want to modify an element, or I may want to only just pass it if it already exists. This is an example of what your code might look like if you were using a variant instead. So a little bit of similarities. In this case, I'm using the in-place structure. Here I'm not, so I'm having to act a little bit more. But it's really very similar. So performance, because I actually care a lot about performance. So in this case, I'm going to create 1 million elements. I'm going to create, actually I think it's about 10,000 keys, because I'm recycling on purpose. Right? So all I'm doing is I'm creating 10,000 unique elements in an array that's 1 million points, and I'm going to see how much it takes to overwrite those values. Potentially insert them when they don't exist, modify it when they do. So here's what my variant might look like. So I'm passing in the array. Obviously, I don't want to measure how long it's going to take me to actually do this. I just want to measure how long it takes me to do the insertion or the modification. Very simple code. I just access it, I increment. Easy? So here's what my map's going to look like. Again, very, very, very similar. So let's look at some results. This is what we get. I think this is a pretty good advocate for maps. Yes. So this is the result. Sorry, well, this is my result here for variant, and then this is my result here for map. Again, I'm just accessing a value, I'm incrementing it, and I'm restoring it. And you'll notice there's a disable structure. Well, because I thought, well, these aren't exactly ideal. We do have in-place structures for both of these things. So here's what that looks like now. So here is truly where I think a lot of the power is. In this case, notice that I can do add or modify. It's just going to take the value. It uses a default value, if it doesn't exist even, and it's going to increment it and then store it. Here's what I would have to do here. So not only can I access my attribute, but I'm actually going to convert it to, I'm doing an in-place access of the data, so I'm minimizing the data copy. But if it doesn't exist, I have to know, oh, it didn't exist, and then I have to insert it. Right? This is a lot nicer. This is what I want to have to deal with more than anything. This also allows you to not have code that looks like this. Yeah, please don't do that. I had a developer actually send me this. He's like, yeah, this is what it looks like right now. I don't have a picture of what it will look like after because it wasn't finished. All right. So yeah, this is what variant stuff can look like nested. Okay. Convinced with maps? Yeah. Okay, good. Thank you. All right. Let's talk about sets. So in this case, I'm doing something very similar. It's again 1,000,000 points, and I want to insert duplicates and see what that looks like. So here's the code it might look like with an array. Now, a set has no duplicates. Right. So in this case, I'm going to have to find whether it already exists, and if it doesn't already exist, I'm going to append it. Oh, and because sets are sorted, just to be fair, I added a sort. Okay, because at any point, I could look at the value. So I can't just sort at the end. I have to sort in the middle. Here's what my set looks like with that 2019. So I like this code a lot better. It's a lot nicer. And here's what that looks like here. All right? So, but then you're going to go, hey, it's in your sort. Okay? So I'm willing to give you that. So let's look at what it looks like without a sort. Obviously, this search is probably your biggest penalty, right? It turns out that the way sets are implemented underneath the hood in LabVIEW is incredibly performant. I don't think we reinvented the wheel on anything. It's just the algorithm is incredibly performant. All right? So think about your set cases. You could put a set in the map. Do all of that. So just think about it. Okay. And then so this is just a recap. It's again to give you a little bit of differences between the two. All right, maybe 2019?
Good.
Good, good, good. Yeah, as soon as this functionality came out, we started using it internally, just because of the simplifications that we got. Question?
Are there ways to get out of the shift register so you can do parallel forwards?
The question was, is there ways to get out of the shift register?
Is it conditional or something?
So, in order to avoid the race condition that it's going to check for a particular value, I don't know that you can. Yeah, that's a good. Oh, so another caveat that I think I want to let you guys know. Let's say that I want to feed a map into a set BI. Then you would have a control and an indicator that is a type map and a type set. You cannot edit on the front panel the value of a map and on the set. Right? The reason is, just think about it, is that there's some checking involved, especially in the set, to ensure that you don't have duplicates at runtime. You could easily, on a front panel, go 3, 3, 3, 3, 3, 3, 3, and then that checking does not occur. Which is why the insert on both the set and the map have a, hey, did I replace it, or did I find it, or things like that. So just in case you... yes?
A quick comment about the parallel forwards. Nice engineering does a lot of that benchmarking. Broadly speaking, for really, really fast transactions that are going to take some, let's say, a few to tens of microseconds, the overhead of invoking the parallel forward will be much, much, much greater than if you just execute it super fast.
That's right.
In this case, obviously, the shift register prevents the reason in the first place to just don't always go to the parallel forward, even if the analyzer tells you that you can't parallel.
Did everybody hear that, or do you want me to repeat it? Okay, small operations, don't bother even trying to do a parallel for loop. LabVIEW Optimize is perfectly fine without. So when it's very costly is probably when the code execution may take a long time is when you want to consider using a parallel for loop. I had a person downstairs at the expert bar go, hey, I have a couple of cores and I wanted to assign, but I need 2 cores. And then one of the answers might be, hey, because you're trying to spawn that many threads, it's actually less performant than if you were trying to do it. Just do it. So just small things to consider. Thank you. All right. So another one, and this is, I think, a fairly complex topic that we can talk about. So in this case, one of the things that we wanted to do at every extension point is our framework, obviously, in order to allow you to extend something, needs to know something about it. Let's say default behavior. And we realize that some client teams may want to overwrite that behavior, but certain teams or organizations may want to inject a separate minimum behavior that can be overridden. It's a little complicated. So, so one of the things to look at is, let's say that this is what the framework knows about. So this is our extension point. It's just called framework. Let's say it's just a class. So it's the minimum requirement. Let's say that a specific project wants to overwrite the minimum requirement. So let's say that I have a configuration loader. Let's say that by default it's accept. And a team may say, hey, I want to overwrite the way that the parameters that we have in our configuration. So I have a separate configuration loader. An organization might say, hey, any team of ours that decides to overwrite this config loader needs to adhere to our organization standards. That's where this gets complicated. So an organization might inject their own minimum requirement, going, hey, anytime a project overwrites the basic framework, please make sure it complies to our organization first. Okay, so this gets a little tricky. And then another requirement that we had at some point was, and we want to be able to make sure that these things could be from a path. And let's say that we want our standards to live on the network that can't be modified by any user. However we want to do that, or from source code control, this is where we want it to be able to come from. So, who's familiar with these two beautiful nodes? All right, okay, a handful of you. Yeah, if you're no stranger to classes, you probably know these nodes. One of my colleagues wrote a great paper or blog post on the true differences between these two things. And let's talk about them just a little bit. So, let's say that this is my situation, this is what I want to enable. So this is our challenge. We want to be able to specify a minimum requirement.
Can you go back to that slide for a second?
Yeah. I'm sure you can find these slides online somewhere.
The link.
Okay, yeah. There you go. The person who wrote this is in this room. You can come talk to him after. He gave me a really nice short link, but I actually like the title here actually expresses what we're trying to show. So I used this title. All right, ready? Here we go. We're going on a trip. Here we go. All right. So here's what we want to be able to do. We want to set the minimum requirement. Great. That's the wire. We want to allow the framework to specify a custom one. Great. So this would be my project specific. We want to be able to overwrite the minimum requirement. That's the org class that I was showing you. And then we'll talk about coming from a path. So let's say that the object I'm passing is of type framework. Everything passes, we're golden. It turns out I haven't overwritten anything. So in this case, yeah, we're going to use the default behavior. Now let's say that org is what I'm trying to pass here. So at this point, I can specify a new minimum because the class hierarchy, which I keep reminding you of in the top right, matches. It goes, yep, I'm at least of this type, I'm good to go. Then let's say that somebody decides to pass a minimum requirement of type project. So now notice that that is the minimum requirement and this is what I'm passing in. What are you going to get? No error. It turns out, it goes, yep, that sounds great, but that's not what I want, right? I want this to fail because I said this is minimum requirement and I'm passing you a parent. And it's going to go, yeah, but the wire matches, right? We have a common, so it's going to go, that sounds great. It turns out, I do not want that node. That's not what I want. So, in comes a runtime type class, right? So at this point, let's run through this a little again. So, if I pass in the project, in this case, and you saw that if I pass in here, so same code as before, with the replacement, I do get an error. It goes, hey, yeah, you're not right. So, great, this is actually what I want, because I want to be able to handle that error, maybe return it to my user and go, yeah, you broke the contract. So now let's look at a good working case. If I pass in a project class and I want to overwrite it with an organization to say, hey, minimum requirements, then we pass, and we're actually good. So it means that here we have fulfilled all three of these contracts, and we are in great shape. And then if you look at the last requirement, you should be telling me, hey, there's no path here. Okay, so let's look at what a path might look like in this case. Here's what we did. We got a little sneaky. So again, right tool for the right use case. So in this case, we're passing in a path. Everybody know get library class default value. This basically, from the path, returns you an object of type LabViewObject. And so in this case, we do need to tell it, well, what to at least make sure it's contracted. So let's go through a use case. I'm going quickly only because I'm running out of time. So let's say that I'm passing an object, and I've defined that obviously the framework needs to know what to get at the end. If I pass it a project, I want project out. That kind of makes sense, right? Because it's at least of this type. So far, alt type prop is working great. It turns out that if here I pass in my organization, I'm going to make sure that it's of the right type. I'm going to pass it in as my input, and guess what? Contract is passed. I have now fulfilled every one of my challenges. And if you want to read way more about it, please read the blog post that you all take a picture of. All right, let's go towards the home stretch here. Okay, now there's another thing that we may want to do, and I forget when we truly introduced this feature, but I think there's a great example in LabVIEW 2019 to do this. Is I want to overwrite the compare operator. So how many of you sort 2D arrays? Yeah? Would you want to change the way that we sort it? Well, so that's one thing that you can do, is by passing in a custom operator class, or comparator class. And so here's an example. I'm not looking for you guys to actually read through all of these, but it's an example of how you can pass in a comparator class that matches a requirement. It actually uses the same, so it's also a vim, and it uses the same type specialization structure that Ryan was talking about for the framework use case. It also allows you to have a default case that basically says, hey, if you don't match, here's what you can use. Oh, and then the LabVIEW team actually thought, wouldn't it be fun to also pass it just to BI reference? And as long as you match this connector pane, it'll use that compare operator. So this is a bonus. We're not actively using this, but we have strong thoughts towards it. So, all right. So, quick recap. Just I want to leave some time for questions. So here was our main objectives, including performance. So here are the main concepts that we went over, right? So an ExpressVI will allow you to dynamically, let's say, look on disk for things to extend. Look anywhere, really, because it's just code. And then populate that in a dialog that your clients could select from. There's the Malleable VIs. So this is what allows you to remove the data type explosion that we often incur. Obviously, sets and maps, right tool for the right thing, so don't use it if it doesn't suit your need. And then here's some of the things that we had to do to allow for future extensibility of the framework, even on things that we didn't consider, as long as you match a minimum contract, which, by the way, somebody could override, then we allow it. And then, obviously, componentization is obviously key to framework extensibility. Okay, yes?
I have a question on the upper left one where it says ExpressVI. Is
Yes.
the expectation there that the user of the framework has to go into the code and then change that ExpressVI?
No, that's the whole point of the ExpressVI. So one of the things that we did was, if the client put code that we knew how to interpret in a particular location, all the ExpressVI needs to know is where to look, right? And so in this case, what it would do is, one is it knew about the framework's default options, plus it also knew, hey, as long as you look here and they're in here and we know how to interpret them, then they can show up in the UI as an option. And so the whole point of that was that we wouldn't have to then update the framework. It was like, hey, as long as you pass, it'll show up, select it, hit OK, and then you're done. The one thing you would have to do is make sure that the ExpressVI knew how to script the thing that you then said OK on. And it's either through a template, which would also be provided. So it could just go, yep, new template, done. So absolutely, there's a lot of power there, and that was why we chose that. Awesome question. What else? Is there anything we didn't cover?
I'm still a little confused about the ExpressVI example.
Sure.
You have to specify in your LabUI file about where to go look for that code, correct?
So not necessarily. So the framework in our use case knew of certain locations just off the bat. The way LabVIEW does this, it uses either NILib, user-lib, instrument-lib. So the examples that we showed are other NI solutions for where do you look. If you have a framework, you could specify, hey, if it's in this location, I'm going to look here. The reason that we showed the NI file is, what if I, as a client, wanted to tell you where to look? And so as long as the framework knows of an NI file, then a client could say, hey, in addition to the ILib, user-lib, look on my custom location, let's say a network drive or somewhere else. And that was a way to shortcut the what did we miss. That's the reason for the NI file example.
Yeah, because I was just wondering how that would play with source code control, things like that. 'Cause I don't necessarily want to have to source code control my whole VI lib or anything like that.
Exactly. So then that becomes a contract with where do you tell people where to look.
And so in that regard, one of the things we were looking at was if someone wrote one component, one driver on an implementation of a function or a HAL piece, could they put that on the system somewhere with all the other ones on the system? Could you replace a piece of it? And could you go onto a system that only had a portion of it installed and actually still get the functionality? So it kind of just showed, as long as we have a contract with our clients, we never have to change that ExpressVI anymore, and they can keep extending in the future.
Yeah. What else?
One other question on the lower right. So, I mean, I'm familiar with the factory pattern. What would that pattern be called now? Does it have a terminology?
We call it the striker pattern.
All right.
This is the unofficial name. We thought a lot about this. It's similar to a lot of other patterns. When we ran it through, hey, what does this actually look like? We were like, it's close to a lot of others, and it turns out the developer was like, hey, can I think about this for 20 more minutes? And we said, yeah, go ahead. And he came up with this, and we're like, this is actually really neat. We didn't have anything else to call it. I would recommend just look at the blog post. He's the one who wrote it. Do we want him to stand up and think about it? He's like, no. Anyway, yeah, what else? Did this help? You guys are like, yeah, this is things that either you've done before that you're going, yep, this is going to be helpful in the future. Yes?
Were there any two examples I could actually look at to go through some of these?
I don't have any to for that. Okay. I like where you were headed. Yeah, in the future, probably. Yeah. All right. Good luck.
All right. Thank you.
Thank you, guys.